How to design a PC board for a signal amplification device. Designing a PC board for a signal amplification device is hard, but with the right knowledge and tools, it is possible to create a successful PCB that meets your requirements. Here, we will provide a step-by-step guide to designing a PCB for a signal amplification device. We will go over the basics of PCB design, discuss the components needed, and explain the design and layout process. So, you will have a better understanding of how to design a PCB for a signal amplification device. PCB design basics. Printed circuit boards, or PCBs, are an essential component of nearly every electronic device. They allow for the reliable transfer of signals and power between components on a small scale, as well as providing a durable platform to mount components securely. But, before you can begin constructing a signal amplification device, it's important to understand the fundamentals of design. You have to consider two things while designing a PCB, like the physical layout of the components, and the wiring that connects them. The physical layout consists of the placement of components and their associated mounting holes and standoffs. You have to place them on the board in such a way that maximizes signal integrity and minimizes crosstalk, while also allowing for adequate thermal dissipation. It is essential to pay attention to the location of each component in relation to the other components and make sure that there is enough clearance for proper heat dissipation. The wiring portion of design involves laying out a printed circuit trace that will transfer signals from one component to another. This requires careful consideration of the desired signal paths, as well as taking into account any electrical noise that may interfere with the intended signal. The trace should be laid out in a way that optimizes the signal transfer, while also minimizing noise and crosstalk. By taking into account all of these factors, you can create the printed circuit board that you require. This ensures maximum signal integrity, as well as reliability and durability of the device. Types of amplifiers. The classification of the amplifiers depends on the frequency of operation, such as DC amplifiers. They amplify signals from 0 frequency to about 10 Hz. Audio amplifiers. In this case, the input to the audio amplifiers is in the frequency range of 30 Hz to about 15 kHz. Wideband amplifiers, also known as video amplifiers, which work on the input signals of frequencies up to a few megahertz. RF amplifiers. In this case, the input signals are in the range of a few kHz to hundreds of megahertz. The components of a signal amplification device. When it comes to designing a printed circuit board for a signal amplification device, it's important to understand what components are necessary for the device to work. Each component has an important role in the signal amplification process and must be included for the device to function correctly. The main components of a signal amplification device include a power supply. A power supply is used to provide electricity to the device and can be either an AC or DC source. Amplifiers. An amplifier is used to increase the amplitude of the incoming signal so that you can hear it clearly or it gets displayed on a monitor. Transistors. The transistor helps switch the current from the power source to the amplifier, ensuring that the signal is sent efficiently. Filters. The purpose of the filter is to block any unwanted noise from entering the system, keeping the output clean. Capacitors. These elements store and release energy, allowing them to control the frequency response of the signal. Microprocessors. Microprocessors help regulate and control the functions of the device, such as gain control and frequency response. Connectors. The connectors allow the user to connect multiple devices, such as an external speaker or microphone. Each of these components plays an important role in the design of a signal amplification device and must be carefully considered when designing a PCB. You must understand the function of each component and how they interact with each other to create a successful product. After choosing all of the components, you should consider their placement on the board. You must place some components close together due to their need for communication, while others should be far apart due to interference concerns. Moreover, you must make sure all of the components are properly grounded to prevent damage or malfunction. You should also choose the right type of trace widths and vias sizes, depending on the application requirements. After considering all factors, you should test the board layout through simulation tools such as Eagle or else. This will ensure that everything works properly before moving forward with the manufacturing process. Ultimately, the goal should be to produce a well-designed PCB that meets all the requirements of the application while also providing reliable performance. Putting it all together, once you have all of the components for your signal amplification device, you're ready to design the printed circuit board. A PCB is a physical platform that connects all the components. It's like a mini city with streets and highways that power and information flow through. Designing a PCB can be tricky and requires both artistic vision and technical knowledge. The first step in designing a PCB is to create a schematic of how all the components will be connected. This is like a map of how everything will fit together. Once you have the schematic in place, you can begin to draw out the layout of the board. This involves mapping out where each component will be placed and which wires will connect them. After the layout design, it's time to think about how to optimize the layout. This involves considering factors like signal integrity, power delivery, and heat management. In other words, this is where you make sure your board won't suffer from electrical interference, has enough power for all its components, and doesn't overheat. Finally, you'll want to add additional features such as LEDs or connectors. Once the design is complete, it's time to transfer it to a physical PCB. You can do it in a variety of methods such as etching or milling. Designing a PCB for a signal amplification device isn't easy. It requires knowledge of both electronics and PCB design techniques. However, if you do it correctly, it can be a rewarding process with great results. Now you're ready to go ahead and fabricate your PCB. To do this, start by uploading the completed design onto a computer-aided design or CAD software. Using these tools, you can adjust any last-minute details before sending the files off to a PCB manufacturer. Depending on what kind of board you are making, there are several different ways to fabricate the board, from DIY etching kits to professional fabrication services. After submitting the necessary files, you'll have to wait a few days for fabrication and then again for shipping. Depending on whom you ordered from, you may also need to purchase components separately and solder them onto the board yourself. For larger projects, some companies offer full assembly services, so all you need to do is plug in the finished board when it arrives. When assembling the board yourself, remember that proper soldering technique is key. If your soldering job isn't up to par, it could lead to unreliable performance down the line. Frequently asked questions: what is an amplifier? An electronic device that can enhance the power of a signal or current is known as an amplifier. What is signal amplification in PCB? The PCB of a signal amplification device enhances signals and maintains frequency. The circuit board turns analog signals into waves, making use of high saturation. How many types of amplifiers are there? The types of amplifiers include DC amplifiers, audio amplifiers, wideband amplifiers, and RF amplifiers. What are the main elements of a signal amplification device? The main elements of a signal amplification device include a power supply, amplifier, transistors, filters, microprocessors, capacitors, and connectors. Final thoughts: a PCB of a signal amplification device helps in a reliable transfer of signals and power between components on a small scale, as well as providing a durable platform to mount components securely. Before constructing a signal amplification device, you must understand the fundamentals of PCB design. You have to consider two things while designing a PCB, like the physical layout of the components, and the wiring that connects them. The physical layout consists of the placement of components and their associated mounting holes and standoffs. Moreover, it's important to understand what components are necessary for the device to work. Each component has an important role in the signal amplification process and must be included for the device to function correctly. Designing a PCB for a signal amplification device isn't easy. It requires knowledge of both electronics and PCB design techniques. However, if you do it correctly, it can be a rewarding process with great results. Would like to know more about the design of a signal amplification device or printed circuit board assembly? Email us at sales@nconline.com. That's sales@nconline.com. That's